Hello everyone, and welcome to our first real video here on our Algebra 2 unit. So we're going to start Unit 1 here, and Unit 1 is something of a hodgepodge of review materials that you've done in other courses, but in order to move forward in this class, you absolutely must be able to do all of these things. So when we get to these different ideas later in the course, we will not be teaching them. They will be considered expected knowledge. So because a lot of it is review, we're going to move through things pretty quickly. So our first concept that we're going to look at today is going to be order of operations. And I'm not going to take the time to teach you order of operations. I'm going to assume you know that from previous courses. What I want to look at is a couple common mistakes that people make when using order of operations. So if you would take a second here and just pause the video for a moment and look at these two problems below. The problem on the left and the problem on the right are two separate problems. Just look at them and see if you can find the mistake, because both of those are done incorrectly. So go ahead and take a moment and pause the video and see if you can find those mistakes. Alright, hopefully you've done that. Hopefully you've paused the video and you've found the mistake in both problems. And when you look at the one on the left, if you look at what our individual there did, they went ahead and followed PEMDAS, or please excuse my dear Aunt Sally, however it was presented to you. They went and used that exactly to the letter. They did not see any parentheses, they did not see any exponents, so they moved right away to multiplication, and they did 4 times 3 to get 12. They did their division, 12 divided by 12 is 1. They did their addition, 7 plus 2 is 9, and they did their subtraction, 1 minus 9 is negative 8. However, that is actually incorrect, and that's a common mistake that a lot of people make when they look at order of operations. If we look down at our correct solution, when we use order of operations, we have to be careful, because multiplication and division, while they're listed separately when you think of PEMDAS, they're actually the same step. We do not multiply before we divide. Multiplication and division are the same step, so we do whatever comes first in the problem as we read it left to right. So in this problem, we should start with 12 divided by 4 is 3, then multiply by 3 to get 9, then we subtract before we add because it comes first in the problem. We do 9 minus 7 is 2 plus 2 is 4. Alright, our second example, our second error problem, involved a division bar, where the individual followed PEMDAS again, and they multiplied, then divided, and then added, giving them an answer of 8. Well, the division bar actually creates a unique situation in order of operations where it creates what's called an assumed parenthesis. It is assumed that there's a parenthesis around both the top and bottom of the problem, requiring you to do the entire top first, then the entire bottom. So you treat the top as its own problem, giving you 14. The bottom, there's nothing to do, so you have 4 on bottom. And then we reduce our fraction, because we always reduce our fractions to lowest terms. And in this course, we leave answers as fractions. Sorry, all you calculator folks that love your decimal answers. We will be leaving our answers in fraction form. So here's what we should be using for our proper form of PEMDAS. We should be doing parentheses, followed by exponents, followed by multiplication and division as a combined step, and addition and subtraction as a combined step. Alright, let's keep on moving. Our second concept is algebraic expressions and substitution. We're going to start with a very simple algebraic expression like 6x minus 5 and ask the simple question of what does that mean? Many people say, oh, well, that means I add 5 and then I divide by 6, when that's actually the solving steps if that were in an equation. But an expression acts just like a rule, where that expression says I have some value x. I'm going to multiply that value by 6, and then I'm going to subtract 5 from that. It is not solving steps. We are simply looking at a rule that we can use to follow. So we're going to use algebraic expressions to do a lot of our review of order of operations, where we're going to have a problem like you see here, where it says calculate x squared minus 3y divided by 5x with a division bar. And then we'll give you values for x and y, where if x is 4 and y is negative 3, we should obviously know from a previous course that if we know what x is, we can substitute in 4 wherever we see an x, and we can substitute in a negative 3 wherever we see a y. So this will be an example of a problem that you'll see on your homework tomorrow. And this is what your correct solution should look like. As you plug 4 in for x, you get 4 squared is 16, and you plug negative 3 in for y. 3 times negative 3 is negative 9, and on bottom you have 5 times 4 is 20. Then you go ahead and do your subtraction on top. 16 minus negative 9 is 25, and you get 25/20ths, and again, we leave our answers in fraction form, and we reduce our fractions. Alright, our last concept that we're going to have in our homework tomorrow, or our classwork I should say, is we're also going to have a brief review of combining like terms, where you have a problem like 3x squared plus 5x minus 7 minus 5x squared plus 2x minus 4. And when we look at this concept of combining like terms at times gets lost when we get into multiplication and we want to make things complicated and we want to start multiplying the x's. We don't need to do any of that. All we have to do here is put our x squareds with our x squareds, our x's with our x's, and our numbers with our numbers. So something I like to do, because I'm an individual that likes organizational tools here, in order to make life easy on myself, I'm just going to underline all my x squareds, and I'm going to circle all my x's, and I'm going to then put a box around all my numbers. Now I'm a little bit limited here on my abilities with this pen, but you guys will have better abilities than I can. As you can see, I have some problems. But when we go to do this now, all I have to look at is lines go with lines, circles with circles, and boxes with boxes. So when I see 3x squared and negative 5x squared, I see I can put those together to make negative 2x squared. When I have a 5x and a 2x, I can put those together to make 7x, and negative 7 and negative 4 go together to make negative 11. And so again, I'm not going to spend a lot of time on this. This is stuff you've known from before. But I do again want to look at one common mistake that we come across with combining like terms, where we have the distributive property involved and we have the distribution of a negative 2. That's the mistake people often make. They don't keep that 2 as a negative number. So when I go to distribute that, I get 5x plus 10, which most people would get, and then the second parenthesis simplifies to negative 2x plus 14, because we have to do the negative 2 times the negative 7, giving us a positive 14. So then we can put those together just like we normally would, and I believe the answer then would be 3x plus 24. So this is what we're going to do in class tomorrow. Again, not a lot of new material. Very, very quick, brief review of some concepts you need to know going forward. And just to check that people watch the video, tomorrow's phrase will be "Go Hawks," as we are celebrating Iowa State week this week. So we need to make sure we're cheering for those Hawkeyes. So we'll see you in class tomorrow. Hopefully you were able to follow this video without any issues.